Hello and welcome to another advanced deep dive. So this time we're going to be taking a bit of a look at artificial intelligence, and in particular one of the techniques we're going to be looking at is something called a state machine. And we'll look at a couple of different ways of setting this up, and initially what we're going to do is set this up in a fairly low-tech method, and then we'll take a look at some newer ways that we can use for setting this up. So I've put together a bit of a test bed here for this, and I'll show you what the different things are. The idea here is we've got two different rooms, so each character will end up having different methods of controlling them. So we've got our two little characters. So for room one, we can show or hide an enemy. And we can also have that enemy make a sound. Same thing in these second room controls here. And we've got these little markers on the ground. These are going to be our patrol points. So what we want is we want the characters, which you can see the characters also have a little speech box above them so we can debug out the state. Really handy thing when we're working with AI. You really want ways of being able to know the state of particular things. Super incredibly handy. And that's something where when you're setting up AI, factor that in as part of the process there, that you're going to want to have debugging tools. You're going to need it because AI in particular, we run into bugs where it won't crash. So we're not getting crashes, we're not getting errors or exceptions. It might just be doing the wrong thing. And those can take a very long time to track down because there's so many different things that can go wrong. I always describe the AI setup in games as it's like a layer cake. And the behaviors, they're the very top layer. They're the delicious frosting on top. And there's so many vital layers below that have to work for that to actually work. If it doesn't, you get weird behavior. And that's what we need to be cautious of. And that's why we need really solid debugging tools. So, okay, we want to be looking at this idea of state machines. So state machines, the idea behind it is we have different states that our character can be in. So for example, our character might be idle, so just standing around, chilling, doing nothing. Our character could be on patrol. Our character could be stopping and searching for the player. Our character could be pursuing the player. So we've got a bunch of different discrete states. So where state machines come in handy is where you have very clearly defined states that a character is in. And a state defines sort of the things a character is doing. So when you've got very clear-cut things like, yes, the character is going to be patrolling. That's their focus. They're going to be moving between a set path, and that's all they're going to be doing. So when you have really clearly defined things like of that, then state machines are potentially useful. With state machines, we also have transitions. So the transitions describe how we switch from one state to another. How do we go from being in idle to patrolling, for example? So we've got different ways of setting this up. I'm going to initially show a very code-based way of setting this up. And our characters both have this character base on them, which is providing a bunch of common things. What I'm going to then do is I'm going to set up a script that's going to be character FSM. So FSM for Finite State Machine. Now with this, I'm going to say that this is going to inherit from character base. And if we go to character base, I don't need to start or update there for it, but I do want them in this one. So what I can do is room 1 is going to be the FSM, the Finite State Machine based AI. So it's going to lose its character-based script, and we will add in the character FSM. So as I said, this is going to be a very low-tech way of setting this up. So if you're wanting to set it up potentially in older versions of Unity, or you are wanting to just have it be purely in a code-based form, then this is where you'll be able to use this kind of approach. So first thing I would be doing is I want a way of describing the different states. So an enum is going to be a good option for this. So let's start off with, we'll have idle and patrolling. So we then want to be able to control our current state. So E state current. And maybe we want to have our, actually, yeah, that works. We can have our current state. So, okay, that's cool. We've got that sort of set up there. Now, one of the things that I want to be able to do with this is I want to then, okay, the first thing it's going to do is it's going to set up into that particular state. So say we are in idle or patrolling, there'd be different things that we would be actually doing there. So a couple of ways that I could go about approaching this. So, okay, set up state, and maybe I'll just do a parent one. And then what I would usually do is I would probably start out, unless I knew really concrete that I had a lot of specific setup stuff for all at once, I would actually probably start out with something like of this, where I have, okay, just it all in that one function, and initially, probably even I would just start with using if statements for it. So if we're going into idle, well, okay, we might want to only idle for a particular chunk of time, for example. So that could be a useful thing. So idle min time, maybe it'll idle a minimum of 5 seconds, and idle max time, maybe it'll idle for at most 10. So, okay, when we're starting in the idle state then what we would want to do is roll our idle time. So idle time remaining, and I would populate that here. So idle time remaining is equal to random range, idle min, idle max. So okay, that'll set up our idle state. What about our patrolling state? If our new state is equal to patrolling, then we probably want to pick a patrol point. So I need my list of patrol points, so let's set that up. So serialize field, list, transform patrol points. And I'm going to need then my current patrol point. So the one that I'm heading towards, so I need to randomly pick that. So my current patrol point, again, random range, 0 to patrol points count. That'll be the sort of setup logic there. Now I want to make sure I change my current state. Let's rename that to current state. So I want to switch this over to new state. And then I want to also, because I've got that character UI, just want to make sure I've retrieved access to this so that I can be setting that particular text. This is something where what I'm going to do is a serialize field protected feedback UI. I want to be able to set particular text there. So this will allow me to do, hey, feedback UI, set the feedback text and set that to current state. convert it to a string. So update the state on debug display. Initialize the based on the state. So that initially will just set it up into the state. It's not going to perform the particular state, but this is an aspect with our state machines. We have this idea of this sort of setup logic, which I'm going to then bring in my patrol points, so I've got all of them. So we have this idea of setup logic, and that's a very common thing of just doing some initial setup. So idle, we choose how long we might be doing that for. For our patrolling, we pick where we're heading to first. So I'm going to, we can see we've already got idle, that text is there. Let's change to patrolling. And what we're expecting to see is the character's text change. So we need to make sure in start, we do setup state for the current one. That will initialize the particular character into that state. So it'll run. And so we're getting a null reference, and we're getting a null reference because we need to link to our UI interface. So let's try that again. You can see changes to patrolling. And if I switched this to idle, then we can see what will happen there. So it stays as idle. So okay, we've got the entry into a state, that initialization and setup running. So that's cool. Well, then we want to update our states. So I'm going to write update state. Now this we don't need to pass anything through. So we'd have update state. So let's think about the different ones. Well, if it's idle, new if current state is equal to idle, then we want to update this idle time remaining. So that's pretty good. And then we want to check if idle time remaining is less than or equal to 0. Well, then we need to pick a new state. So void pick new state. So what we could do here is we could say if the current state is equal to idle, then maybe what we do is we switch to patrolling. So if we've been idle, we then go on patrol. Otherwise, we switch to idle. This will just manage that transition between the particular ones. So update idle time remaining. And this is the thing, so with states, they have their setup logic, so they have an entry point. They have update logic, and then they have transitions, so criteria for them switching from that state to another particular state. Completed. Otherwise, current state is equal to rolling. Now this, if we started to put this here, this would actually get quite lengthy. So this is where we would start to do things like update state idle. We start to split this logic out into our separate functions. And we'll find that we'll end up with progressively more and more of these as we write more and more elements of this. And that's the thing, you don't get too hung up initially on writing the perfect version of the code, especially the first time you're writing something. It's not going to be perfect. It absolutely won't be, because it can't be. Until you've written something multiple times, you don't know the pitfalls that you'll run into, the potential areas and ways that you could optimize it. So first few times, it's going to be clunky, it's going to be messy, that's okay. don't use that as a way to actually sort of build up momentum by just diving in and working on the stuff. So, all right, idle, what we should be able to see at this point is if it starts in idle, then after a chunk of time, it will actually switch over to patrolling. So let's test that and make sure that's actually happening. Because again, with doing this, we want to be testing the individual pieces as we're going along. So it'll be running. We can see that it's currently there in idle. So when it's patrolling, we just want it to, and there we go, switched over to patrolling because the idle time was elapsed. So now for patrolling, well, we have a point that we're heading to. So we know when this update runs, our setup is already run. So we know we definitely have a patrol point. So what we could do is vector to patrol point is our patrol points, current patrol point, position minus our position. So that gives us our vector to it. Then we could check if we've reached it. So we could have, for patrolling, reached threshold. So 0.5. So we could be checking here for F, our vector to the patrol point magnitude is less than or equal to this. So have we reached the patrol point? Reached patrol point. Then what we would say is our current patrol point is equal to current patrol point plus 1 modulus with patrol points dot count. So advance to the next point. Doing the modulus just means that what will happen is we've got 4 patrol points. So current patrol point will go 0, 1, 2, 3. And then rather than being 4, it will go back to 0. So it will continue to loop around. So modulus for doing stuff like this with patrol points, really, really handy. It's a really effective way of actually making this stuff work. So okay, we'll have our point, so we can move towards it. So we want to do our vector 3 move towards. So I want to move our position towards the patrol point position, and we want to have our movement speed. So float movement speed, and let's say we move at, let's keep it fairly slow, 2 meters a second. So we can move. So that will be good. That will make us move towards the point. Move towards the point. We also want to face towards it. Face the control point. So we can use our transform look at. And what we are going to be looking at is our patrol points, current patrol point, and we want to give it our world up so that we are keeping the character level. So okay, now they'll be patrolling. So we should see them start in idle, chill for a little bit, and then move to the next stage. So it's very clear-cut, rigid, what's actually happening, what its criteria are for changing or doing anything. And this is a really important aspect with state machines. They are a much more rigid structure, and they will do they do their very specific thing, and they do only that. So while it's patrolling, it will just keep moving around, and because we haven't given it any reasons that would cause it to interrupt that, it will actually not. It can't. We haven't set up anything for that. So rigid structure. So we need to then do things like, okay, well, we could, if we think about it, visual information versus auditory information or sound information usually is going to get treated differently. When we see something, it's very definite, it's very clear cut. When we hear something, we know the rough location it's from. So we want a difference in behavior here in terms of, okay, heard something, saw something. So let's think about what we want these states to do. So, okay, well, from a setup point of view, so setup's usually what we would do first. So if the state is heard something, well, I think with the case of having heard something, we want to look at it. And just that. That's all we want to do, is look at it and nothing else. So when I've heard something, well, that heard something, we need to know what we've heard. So I'm going to have something here that is keeping track of last heard location. So the location that we last heard something at. Now, we don't have a position, we don't have a transform, so we can't do a look at, but we can do a quaternion look rotation, and we can take our last heard location and our location, so we can give it the direction to look, and a vector 3 up, and then override our rotation. So look at the sound source. Now, it's going to be a little bit similar for hearing something. So seeing something. So if our new state is E state saw something, then what we're going to do in that case is look at the enemy. Now, in this case, we will actually have a transform. Last seen enemy. So with this one, we can actually do a look at. So look at, tell it what to look at, and again, give it a sense of up. So okay, in both cases, when we hear or see something, we will look at it. The difference, though, is, so if the current state is heard something, and we'll do update state heard something. We'll have a similar thing for if the current state is saw something. So update state, saw something. So let's look at implementing these. So the idea behind having heard something, update state, heard something. So we've heard it, but it's indefinite information in that it is, we know that there's something over in that location, but we don't really know anything more than that. So what we could do is we could move towards it. We could do nothing and just stare focused on that location would be an option. So we're not going to have it do anything initially, but that's where we could have logic in there. Whereas the difference for something, if we saw something, if we see it, we want to continually track at it because we know where it is and we want to be keeping it in view. So we will retain this looking at it. So, okay, well, we've got criteria here, but how do we enter into these states? And how do we exit them? because it's not as simple as, oh well, we saw something, so yep, we need to have a bit more information there. Same with having heard. So if we've heard something, what we would probably do is listen time, let's say for 5 seconds, and then we would have listen time remaining. So what we will do is when we hear something, we will keep sort of listening and focusing on that until time has elapsed. So our listen time remaining is our listen time. So we look at it for a set time. So our listen time remaining would then get updated here. So this would become like that, and if our listen time remaining is less than or equal to 0, well, then we pick a new state. And this could be, rather than just actually doing the picking here, I'm going to say we immediately go to patrolling. So nothing heard, patrol. So we want to force it to go back to patrolling. And I think we can start to do a similar thing here, where actually we get rid of this pick new state and we end up doing this, where we say, yep, if the idle time has elapsed, we go to patrolling. And patrolling is going to be a common one that we return to. So it means we can get rid of our pick new state function. So we're progressively building up bits and pieces of this. So, okay, heard something, we'll continue looking at it. And the source something is different in that, okay, well, we want to keep looking at it until we can't see it. So that's going to be a little bit different. But we also need this stuff to come in and provoke or cause these state changes. So we can actually see our character base has these functions. So it actually already has things that it will receive to tell it that particular things have happened. So I'm going to make these virtual. And then I can use these as my hooks for causing changes in behavior. I'm going to put these up here. And what will happen is these will actually run the base version. So these will say base on enemy detected, enemy. But then when that happens, we've detected an enemy. So last seen enemy is equal to enemy transform. Setup state, so we switch to a new state. E state saw something. So we're reacting to having seen the enemy. When we lose the enemy, well, base on enemy lost. And in this case, well, if our current state is equal to saw something, so if we're tracking the enemy, then setup state, and we go to patrolling. We've seen something, we've heard something. So base on sound heard location. And what I would also do here is last seen enemy, I would set that to null. So just making sure we're cleaning up things. So I would say last heard location is the location. And we set up state. E state heard something. I'm going to rename setup state to switch to state, just as a bit of naming for it. So, okay, we've got a few different states here then with this, and what we should be able to see is the character will start an idle, and then they will go to patrolling, but then we can make a noise, and they'll be focusing on the player. So I'll be looking over here. So they're in idle. Now we're expecting to see them switch over to patrolling, which they do. So we'll let them move around and we'll let them get to the far side of the room. So here, let's make a noise. Well, the making of a noise didn't cause anything to stop. Let's try showing the enemy. So those are not coming through to it. So we just want to check that, and this is what can happen because we changed the classes. We just need to link these up. Now, in a larger scale system, what I would normally do is I would set up a system for essentially a sound manager and a visual manager as well, so that we have stuff for relaying all of those notifications. But let's test this now, and we'll be able to see. So it's still an idle. And then we want it to go to patrolling. It's patrolling, so let's make a noise. So you can see it's heard something, it's looking over this way. It'll keep doing that for a bit. Then it goes back to patrolling. Let's show the enemy. Now it is locked on the enemy location, continually looking at it. So as this moves, it's continually tracking it. And then we hide the enemy, and it resumes going back doing what it was. So general structure with our state machines, and in particular some things with this sort of setup. So you saw we built it iteratively. We started with some essential states that we knew we were going to need. We set them up in a very rough form initially, but then we started to break that logic out. We started to set it up to be a bit cleaner, a bit more modularized, keeping these functions from getting too large. For a given state, we generally had logic for, we'll do this when you enter this state. And here's logic for how you update it. In some cases, you might need to have a specific logic running for when it exits from a state. And that's why always having a function that's your central thing for doing that switching can be handy, because that central function, I could check here, well, what was my current state? What am I needing to do there if I need to do any cleanup? So it might be relinquishing some resources, dropping some items, things like that. We have our update logic, and then within the states, they're very self-contained. They're doing their particular logic there. They're deciding when they should switch to another state and what state they should switch to. And that's a key thing with state machines. The current state that is running, it decides what other states can be switched to and under what circumstances. So it gives us a very rigid structure, which is, from a testing point of view, it's very easy to test. The thing to be conscious of with using state machines for AI is that it can lead to AI that's a little too rigid. So you might want to have a little bit of fuzziness in your transitions. Otherwise, players can very easily identify the patterns and exploit those and trivialize the AI behavior. Now, setting things up with this sort of method with lots of code, it's an okay method, but you can imagine, it's very hard to visualize it immediately. Now, we could have sort of visual tools that we're using accompanying this. That's absolutely a viable thing that we can do there. So we can have like state diagrams for mapping it out. We can set up flowcharts, things like that. But setting it up with lots of code, this is something where it is a much more manual process. It is more error prone. It's a lot easier to tell what cases we haven't picked up on because we can't visually sort of see all the entries. So we've got alternate ways that we can go about approaching this using visual solutions. In terms of visual approaches, we've got a few different options of tools that we can use for this. But looking at stuff that's specifically built into Unity, one of the things that's there in the newer versions of Unity is a visual scripting solution. So this is the bolt system that Unity acquired, and then the Vintegrated there is a built-in part of Unity. So if we take a look at that, so we'll no longer need room 1, but we will need room 2. So with this, we can go down to create, and these are here as an asset. So they will be there under, we have this visual scripting one. You can see we have two different types of ones. We have states and we have scripts. So scripts are more for if you're just performing sort of general sort of gameplay, level logic, things like of that. Whereas states are more tied with the kind of thing we're doing here, where we have specific behaviors that we want the character to be engaging with. So in this case, we're going to start with this. So character visual FSM. I'm going to use this as the naming setup for it. So this is going to go onto AI2. And what we're going to then do is they are going to have that character UI interface. And we can see we have this state machine one. So we can have that state machine one, and then we can bring this over so we can link up the graph. Now, one of the things that you might encounter, this is not an unusual thing in the Unity with adding in the visual scripting. I've found this a few times. What this is, and you can actually end up, so there's stuff you can just remove for this. It's particular aspect with the version control thing here, because this is for the plastic SCM one, and that tends to cause these errors at the moment. So I am just going to remove that so we don't get erroneous warnings. Particularly in the approach of you want to always have no warnings in the project. So something like this, where we've got something erroneously causing warnings, I'm going to remove that so that I'm not encountering it. So that will clear that up. So, okay, we've got our graph here. So let's edit this graph and we'll be able to see what these look like. So these have good performance. They generate code. So they're not something that's runtime interpreted. They do actually generate code-based solutions for it. So the performance is really quite good for it. And it can be, for something in particular like state machines, it's a really easier way to sort of view the logic, because you can see the individual states, and that makes it significantly easier to work with. It does take a little bit of time sort of during initial setup stuff, or if you are adding in a whole bunch of new classes, there may be additional updates there that you need to do, which do take a little bit of time, but it's a very manageable amount of time there. So what we'll be able to do is we're going to lay out all of our states visually. We're going to set up all of the logic for them visually as well. So it's built up its database, so cool. So let's start with what we want to do is we can have our different states. So we've got a bunch of different ones. So let's start off with, this is going to be our patrol state. So I'm actually going to do patrol as the first state. So you can see we've got stuff here where we can, if we double click on this, we can say, well, okay, here's what to do when you enter the state. Here's what to do when you exit the state. And we can then set up variables. So we've got different types of variables here. A object variable is more what we would be looking at here, where it's something that's tied to this particular instance. So I'm going to need my patrol points. So I can add that in, and we can control the type of stuff here. So that's a really handy thing where we can say, okay, a list, and we can indicate the type of thing that it's a list of. So really, really handy. So I can say a list of transforms for our patrol points. So that will work quite nicely. And we're going to need to be able to pick our current patrol point. We can add that in. That's going to be an integer. So when we enter, we want to pick a random value between two, and we can see we've got the different versions, so between our integers. So we can then also bring in our patrol points, which would be able to get our length or count of that. Let's count for a list. So the count of items in the collection. So we pick a random one up to that. And then that will actually, and this is one of the things, making sure these charts are neat is important. So we'll pick a random patrol point on entering into this state. And then what we want to do is we want to set a object variable. So we are setting our current patrol point. So there we go. We enter. We pick a random value up to the patrol points, and then we've selected that as our particular patrol point. So then in update, well, we need to get a vector to that point. So we're again retrieving our patrol points, but we want to, from that collection, so in particular from the list, so we can say get list item, and we can grab our current patrol point, so we're retrieving that. Now we can bring in our list of patrol points here multiple times if we need to make stuff a little bit neater. So we can do like if this, that will grab, I'm going to put exit up here because we're not using it. So, okay, this has grabbed our patrol point. So we've now got our particular one. And then, okay, that gives us a position. So, well, it gives us our transform. So from our transform, we could then extract out our position. So we can see, okay, transform, getting that's position. Because we know the first thing we need to check is have we reached that patrol point? And then we can do vector 3 math, so we can do our vector 3 and we can do vector 3 distance. And we can check the distance to ourselves. So for example, we could say this, so we can refer to ourselves, can get our transform, and in particular get our position. Get our position, we get the distance. So all of this is to get us to the point where we've then got that distance. Well, we know we need our point reach threshold. So patrol point reached threshold. And we know that's a float and that we want that to be like 0.5. So we can do ifs, we have our comparisons. So less than, and we can usually track down then. We've got this, so if that distance is less than or equal to our patrol point, then we know we have reached that and we go to the next point. So this is the way the ifs end up looking. We calculate the Boolean and feed that in. So if it has, and you have to connect through these flow things as well. So we have to say that we're going from update, we're calculating that distance, then we're doing this comparison. So it does get a little bit messy potentially. Keeping flowcharts organized is an art in and of itself in terms of where and how you position things to try and make it look as neat as possible. I try and keep there to be a level of symmetry with it. I find tends to make it a little bit easier for following. But so we're getting the position of the patrol point. We're getting our position. We're getting the difference between them. We're checking if that is less than the threshold, and if it is, then what we're wanting to do is update that patrol point. So we would do add, and we can actually just probably also get this from here. So we can say we've got this, and it's just scalar values. So we add 1 to it, and then we would do a modulus with, for the modulus, it needs to be with the count of the patrol points, which again, we can retrieve this in multiple locations. Because we can just say collections, count of items, modulus with that. And then we will do a set of the variable. So set object variable. So if it is true, then we do a setting of the current patrol point. So it's a bit more long-winded for setting this up compared to what we would write otherwise. But it allows us to visualize the logic and the flow of things. And this is something where we are relying heavily on coding knowledge to be able to set this up. We know the types of functions to be looking for, and that is a big time saver with stuff like this. Because we've got that set, but we still need to actually move and look towards it. So we still need to then handle that process of doing the move towards. So we can check. So we do have our move towards, so that's good. So our current, well, our current one is pretty straightforward in that we have that back over here. And this is where I will usually duplicate these, or you can stash them in a temporary variable, rather than running the lines behind everything. That gets a little messy if you're running stuff sort of just behind everything. So, okay, well, we've set where we're moving from. This position here is where we're moving to. So again, that's something where what I would do is we can take our patrol points, we can say from our collections, our list item, get list item, grab our patrol point, can link that up, then transform position. So then this is where we're moving towards. So again, we can move these. So they're a bit closer, a bit nicer set up. And this is, as I said, this is always the challenge with visual-based methods, is trying to keep everything neat. Is a massive challenge, because we've got to, calculating that, well, we need our move speed. So we need another variable here that is movement speed. That's also going to be a float and start at 2. So then we can retrieve that, and we can multiply that. So it's going to be a multiply, but we also need delta time. So we need time dot delta time, because we need the amount to move this frame, and that links into there. So we can move all of this here. That move towards could actually do a move per second, so we do have that as an option. Set this up like this for now. So we're trying to always have this as neat as we can. It isn't always feasible or doable to get it super neat, but we do the best we can. So this gives us our new position, which then we can set our transform's position. Because we've got this, and we can then do a set position on that, which we have our new position we've calculated here, and that's one where I'd probably chuck in another this unit, just again for neatness, because this lets me make it look like that. We need to link up our false, and this one all goes to there. As I said, it easily gets very messy very quickly, because we have all of this set up here, and then we try to have this as neatly as we possibly can, but there is a limit to how neat you can make this stuff. It is tricky to keep it neat. I'm going to put this down here and move this more up here. So, okay, it's convoluted to say the least. And this is all of the stuff in terms of the logic for making this work. And if I go back to the AI, so that was just this state. So just for the entry, and we also needed to actually run that particular function, remember, as well. We wanted to be updating the UI there. So we actually need to have a reference to that, because with this, I can actually get rid of my character base in theory, but I'm going to keep it there for now. But I want to talk to that character UI interface. So the character UI, which I can add that in, and in terms of with this, any of my particular ones appear here. So that's one of the really handy things with it, that they appear here, and I can link that up, because then what that lets me do is I can see then particular ones that I can actually run with this, because I can see that set feedback function is here, and the new text I can set, okay, that is now in patrolling. So I can see that I can retrieve the particular one, because what I would do is then when we've run this, we just update and tell it that, yep, we're in this state now. So it is a lot more setup with doing the visual ones in terms of this and this is one of the things with the visual tools are really handy. I'm a huge fan of visual tools, but don't be under the illusion that they are somehow automatically easier to get set up or easier to debug. They're not. They're easier to visualize things. So they give you a really clear visualization of the components, the elements of stuff, but they're not necessarily easier to set up or get up and running. Because this, okay, we've got it there. And if we take a look at the AI2, we've got that linked up. We need to link up our patrol points. So we can set up particular values in here. So let's make sure this has got our patrol points. 0.4. So let's see what happens if we just run that. If we get anything particularly happening to begin with. Well, we can see it's picked a point, moves towards it, and it gets stuck there. So it's not then going and picking it up, because we can see its current patrol point that it actually picked 1.5. So let's take a look at what we've got happening here. So we've got an issue with where it is picking our random points. So this is where when it has actually reached a point, because we're handling this scenario where it's moving to the next one. So we've got that set up. And what we need to do is, if we just run it again and just watch behavior here. So it's running. It heads to that point, and we can see the paths that it's heading through. This is one of the nice things with this. Now, what we can see is that current patrol point changed, but didn't change the way that we would have expected it to. Its type is getting changed to an integer. So this is where we need to look through and see, okay, well, what are the cases where that patrol point gets modified? And then what we're able to do is, well, we don't have it looking at the particular thing yet. So we can make it that that's the next step, that we have it actually look at the particular ones. Because we're doing the movement, but we want to add in a look at. So we can do transform look at, and we can run that here. So we want to use our world up, which will set that just to 0, 1, 0. So that's going to correspond to vector 3 up. And then we are already retrieving the particular one to be heading towards here. So we could link that up like this to retrieve actually we needed the level earlier. So now it will look at the particular object as it is moving towards it. So if we test, should see that we're then again getting similar behavior to what we did with the other one, where it faces whichever things it's heading towards, which is good. So, okay, we've got that set up, but what about our other states? Because this has just been our patrol state. What if we want to have our idle state? So we want to have idle. We can see these two are looking different. So this one's our idle one. Notice this one's got a green indicator, whereas this one doesn't. So that's because this one is the actual initial one. So this will control whether these actually run at the start. So we don't want patrol to run at the start, we do want idle. So, okay, we've got our idle state then. So if we go into it, and we can, from our patrol one, we could grab a little bit of stuff here in terms of this setting the feedback text. We'll lift that logic and put that into idle. So in idle, we'll bring in this. So we'll definitely set that text. And it's going to be doing more than that, obviously. That's our starting point. We set our text so we know that we have entered that state. So that's good. So we've entered that state, and while we know that for the idle, we wanted a min idle time, and that min idle time was a float and was 5 seconds, and then we also had a max idle time, and it was also a float, and it was 10 seconds. So we know that the first thing we needed to do was we needed to pick a random value, and that needed to be between min and max. So we know we need that. So we've picked a random value, so that's good. we know we're going to need to keep track of our idle time remaining. So idle time remaining is going to be our float, because we want to then store into that. So set variable. So we set variable, and that's our object variable for the idle time remaining. So we just set that. So, okay, well, we've updated the text, we've set our idle time remaining. Then, well, in this case, we know we're going to need to update our idle time remaining. We know we're going to need our delta time. So we can just actually do our time, get delta time. We know we can retrieve our idle time remaining. And we know we can do a subtraction. So we can say, okay, idle time remaining, subtract this. We can then do a set of our variable. So this is what links over. And again, we have that challenge of trying to make it look neat. It's one of the things that finding a good solution for this with visual tools is always a challenge. So we're updating our idle time remaining. Well, now we need to check if that is less than our particular value, because we need to know if that is less than or equal to 0. So is it less than or equal to 0? We have our if. Check with that. So if it is less than or equal to 0, well, then this is where we need to change state. So if we look for state, well, we can access our state machine, and we can see we've got, things like trigger state transition, but we need to know what we're transitioning to. So we need to know our state machine. And if we take a look at that, well, we can see a bunch of different options here, but nothing that really looks sort of like what we're after. We can see ones where we can get the reference to it. So, maybe from that state machine reference, we can then do the change, but it's not something that then immediately shows up. We can't see the particular ones here. So it's not something that's necessarily well communicated. The auto-completion stuff with the transitions isn't, or with the visual scripting isn't as good as it could be. We type in transition and it's still not sort of super clear exactly where it's needing to be linking to. So how we have to actually go about setting this up is we can say, okay, well, let's make a transition from idle to patrol. And you'll notice the block gets added in here. And then we put the logic actually in here for that triggering of the transition. So what we would do is here, where we were doing, the updating, that's all fine. But what we would actually need to do is we remove the logic from there. We go into our transition here. We can paste these in, and we need to then retrieve our idle time remaining. So we can do that comparison. If the idle time remaining is less than 0, so it's the object variable. So we split out our transitions. They're not part of the actual main sort of logic. So you can see we'll trigger the transition. So that's with that particularly sort of set up. So what we can then do is, okay, well, let's see if, what happens with that. Because what we should hopefully see happen is it runs, starts in idle. After, you can see our idle time remaining, so that's ticking down. So we're looking to see, is that going to then automatically run? And it doesn't. And that's because we haven't actually done anything to activate this path. So we need to have our update event needs to come in to here. Now, if we go back to this and go back to the game and then run it, and then we watch our idle time remaining. So it's ticking down, still in idle, it's going to hit 0. Then it starts patrolling. So if we go back and look at the setup here, we've got patrol. So we start in idle, we go to patrol. In idle, we're doing our setup logic. We're doing the random rolling of the time, everything like of that. In update, we're updating that time remaining. But the actual switching happens in this transition block that we have to make. That means then if we want to have things like our saw state, because we wanted that state for having seen something, or heard something, sorry. So we'll do heard something. So we know with heard something, it needs a last heard location, and that's going to be a vector 3. So we know heard something, its logic is going to be pretty straightforward. We're going to have the same setup for we need to update the UI. So we know that's just a given. We update the UI to heard something. And then we know that then what it needs to do is it needs to look at. So we can do transform look at, and we know we can use a world position. So that's a handy thing where this one allows us just to provide a nice world position. So we can do that with the last heard location. So that's good. It will look at it. We know we want to then have the time. So we had our listen time. So we would have listen time. We'd also then have a listen time remaining. So listen time and listen time remaining. And we know what we would do in this case is we would be doing a set variable, and we're setting our listen time remaining, and that would be being set to our listen time. So we've got our initial logic there for having seen something. We know what we would then do at update is we would retrieve, and we can just actually do this. We would retrieve our listen time remaining. We know we would get our delta time. And then we know we would be doing a subtraction. And we've got our scalar maths and subtract, and we're subtracting delta time. And then we know we're doing a set variable here. And again, we're setting our listen time remaining. So, okay, we've got our heard logic. We're changing to say we heard something. We'll be looking at that last heard location. We're setting our listen time remaining. So that looks good. We need our transitions though, because we know we go from heard something to patrol. And we know logic-wise, again, we need an update. So we need an update here. We know that with that update, what we're checking is, okay, well, listen time remaining. And we know we're going to need a less than or equal to. So it's going to be the same logic that we had. It's just that we're having to set it up through this different method. So we know we trigger the transition. So, okay, that logic is set up. So if it gets into the heard state, it can then go from the heard state back into patrol. And this is one of where the advantages with these visual methods, where we can see really clearly what these state connections look like, and we can see all of the state connections that exist. But we need to get into that heard something state first. So that's the challenging thing there, where, okay, well, we now need, because we've got these functions here, but how do we have those functions talk to this? So we need to have something here where these are managing to actually listen to things, where there is information being able to be passed in, setting stuff like a last heard location and that. So we'll take a look at how we can actually do that, because we could be in any particular state when we've heard something, because we could be in idle and have heard something, we could be in patrol and have heard something. So, okay, well, let's make a transition from idle to heard, make a transition from patrol to heard. These are going to use similar logic. So, okay, well, what do we want to have here? Well, if we look at our logic, we can see what we can set up in terms of events. So we've got this thing of custom events. Here we can see that we've got here obviously all these other particular ones, but the key thing is we can set up a custom event that will then activate stuff. We can set the number of arguments, so that gives us a way of interfacing this. So okay, we're going to say this has one argument, and this custom event is then going to not necessarily trigger that transition. What it's going to do is it's going to set, firstly, our last heard location. So it's going to set the last heard location, because that's going to be what that variable is that comes through. And then after it's done that, then it will trigger that transition. So that's going to be that particular event. Now we can give this a particular name. So on heard something. So that looks good. And we can use the exact same logic in R1 for the patrol one. So exact same logic, triggers the transition. Good. So then we need to be able to run that event. So let's take a look and see. At the moment, what we've got is our logic here, our player 2, talks directly to that particular character base. But let's see if we can talk to our state machine. So we have particular ones here, but we don't see our actual sort of event there. So, can we have this activate that custom event using that external stuff? So to hook this up is a little bit of an involved process. And we actually do need to have some custom code for this. And what we can do is I'm going to, rather than using character base, actually no, character base would be fine to use for this. So what we can do is we can say Unity, visual scripting, custom event, trigger, and then we would say on sound. Actually, we need to give it the target game object. So that would be going to ourselves. And then we would be saying on sound heard. And then we need to package up our actual data. So location. So we can do this for each of these particular ones. As a way of passing that information through. So this will be our on-enemy lost, on-enemy detected. So our base ones should run through that. They should set that last herd location. Let's find out. If we keep an eye on our AI, we want to make sure everything's linked up, which it is. So what we were expecting to see is our last herd location will change when we tell the enemy to make noise. So we can see that it's just in idle at the moment. We'll let it go to patrolling and actually be patrolling around. And then let's make noise. So we can see it did, we got the heard something message, but we're not getting the actual particular data coming through. So we'll take a look at that. So when we're working with these custom events and we are triggering them, one of the things we want to watch for is making sure that these names match. Because we're using just strings, it's really easy to have them not match, which was causing this. When I had this as on heard something, it was actually failing to work. Whereas now that I've made sure the text names match, what I can see is then when I have this make a noise, I look towards it, and if I look at the data for the character, they're listening for a bit, they'll keep then going about their business. If I make noise again, then they look over towards it. So that means I can then set up my final state. We've got heard something, and then we also have my state for saw something. So we'll saw the enemy. So similar to with the other ones, when we enter, we need to make sure we set the feedback text. So we'll do that. Saw enemy. Link that up. And then we know that the key thing with this is as long as they can see that enemy, they are going to keep looking at them, which means we need the variable here for the tracked target. And if we look what we're sending through a game object. So we want last seen enemy. Add that in, make sure it's a game object. Then all we're needing to do in update is we're going to be doing a look at, and we'll be looking at a particular target. We've got our world up location. Now our target is going to come from our last seen enemy, and we want their transform. So we just want to retrieve the transform, because we've got coming in is a game object. So we just want to say get transform, and we can do that. So we won't be needing anything with the exit state, but we could set up, again, the usual, we could set up stuff there if we needed to. So that will keep it always looking at it. We're displaying the particular text. So then we can set up the transitions to this. So, okay, idle, we'll have a transition to seen the enemy. Patrol, we'll have a transition to that. And heard, we'll also be able to transition over to that. Now, all of these will do the same logic. So the process for switching to them is going to be the same. We have our custom event, which we know we're looking for on enemy detected. We'll have one parameter, and we're going to need to be doing a set variable, because the first thing we've got to do, obviously, is set that last seen enemy to this. Then we activate the transition. So we've got that. So all of them will use that same transition logic. And we could, with this, we could set up some custom blocks as well that would mean that we're able to do, group some of this logic so we're not repeating things. But so all of our states we can then see can switch to the seeing of the enemy. Then from saw enemy, we know we will have a transition from having seen the enemy back to patrol. And that is also going to have a criteria here in that rather than being enemy detected, it's going to be on enemy lost. So we lose the enemy, we perform a transition. So let's test. Let's see what happens with this. So we should be able to have that switching between the states. So let's make the enemy visible. So they're looking at them, which is good. And we can see if we move not our player, let's move the target. They're turning to face that. If we hide them, they go back to patrolling, make them visible, so the state transitions are happening nicely while we've got it having been heard. We can then switch to them being visible. So really easy to visualize the transitions that are happening here. And this is one of the advantage we get with visual-based methods, is that we can see all of our connections. So I can see that, yep, from patrol, I can go to seeing the enemy. I can go to, having heard something. So let's just map out all of the possible types of things that could happen really easily. Whereas with the code-based ones, it's a lot easier to miss. Because, for example, with heard something, we can transition from this to having seen the enemy, but it's not as clear cut. We have to do a bit more searching around. Whereas with this, we can just directly see, well, no, there is a link between having heard something to having seen it, and we can inspect and interrogate the link there for it. It is obviously a lot more setup. There are things that we need to watch for in terms of we're using a lot of freely entered text, which that's always error prone, as we saw with picking up those custom events. Things can go wrong with that. So that is a thing we do need to be cautious of with this. So just recapping a bunch of stuff here with the state machines. In general, for when you're looking at using a state machine, where you would be looking at that is when you have stuff that can be neatly defined into particular clear-cut states. I am now doing this task. I am now doing this task. So it's based upon the behaviors that are being carried out and the things that it's reacting to. That's the characteristic for state machines. We have clearly defined types of things that it's doing and clearly defined reasons for it switching between them. We can set those up in code. Now, the thing with the code setup is it is a bit more manual, a bit more laborious for setting it up. It's also easier to potentially miss areas with it. We also saw setting things up with visual scripting, so using the visual scripting system built into Unity, which is easy for us visualizing our setups here and seeing what our transitions are. But as we saw, even with quite simple states like our idle one, the logic, the amount of blocks does get to be quite a bit. And so it is quite a bit to keep track of here. Our transitions, it's really easy to visualize them, but then we're having to make sure that we're getting the names of things correct. It's very easy to get lost with the setup for it. It's a viable option, but it is something where we do need to be a little bit cautious with. It's not just an instant solution where it's like, hey, it's a visual method, it's going to be really easy. It's not necessarily going to be easy. It is that you run into different types of problems. There's particular types of problems you won't run into, but there are other ones that you can run into. So it is something to be cautious of with the visual approaches, but they can be really great for planning things out and for setting up some of your infrastructure there. So dive in, experiment with it, have a bit of a look at it. We're going to be looking at other AI techniques as well for doing these things. So this isn't going to be the only technique that we look at. We will look at other ones, and including also other components of AI that we'll be looking at other points in time as well. So dive in, experiment, and see what you can create with it. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects. They're freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.